Hi everyone, it's Ken here. In this video, we're going to make the frame for this clock using CNC. There's an ongoing debate as to whether it's easier to do things using CNC or to do it by hand the way Chris on the Clicksping channel does. By the end of this video, we'll all be in a position to answer that question. I hope. I'm about to set up the cam for the frame now. And the frame is actually quite large. It is almost 14 inches in length and almost 10 inches in this direction. The problem I have is that my mill has a work envelope, which is the maximum size it can cut at a time, which is roughly about this big.
Houston, we have a problem.
You're going to need a bigger boat.
Well, obviously, this presents a problem. And, one might think, well, why don't you just buy a bigger mill? Well, that's a solution that just has no end to it. I could have an enormous mill that's capable of machining, let's say, a V8 engine block out of a solid block of aluminum. But you know that as soon as I finish that, I'd want to machine a V12. And then I would once again need a bigger mill. So, rather than thinking about always buying new tools, which is cool, we need to think about working smarter. Let's take a look at my thought process for how I'm going to machine this. If my machine had enough X travel, which is this direction, to reach the full length of the part, we could take advantage of the symmetry along the center line here. So we could machine half the part and then flip it over and machine the other half. But as I've stated, my machine will not reach all the way to the end here. In fact, I went back and measured it, and if I really, really push it to the limit, which I don't like to do, pushing it to the edge of its travel, I can get just about that far. But in Y, which is this direction, I can get down to about here. So what I'm thinking is to mount this part and machine what I can reach here. Then what I could do is shift the part to the left and machine this part. Then flip the part over and machine this part using, the same toolpath we used here. So in 3 operations, with moves and flips involved, it is possible to do this. But how do we register this? How do we make sure that every time we move the part, it's re-registered exactly where it has to be? Because if it isn't, we're going to have seams everywhere, which I would prefer not to have. So my thinking is to make a fixture plate. Now you all know that on my mill, I have a standard fixture plate that I made that I leave there most of the time, and it essentially is just a hole pattern that I can, screw things to. So in this new fixture plate I'm going to make, which is just a 1/4 inch piece of aluminum, these holes here and here will hold this fixture plate to the one beneath it, the standard one that I keep on my mill. Once that's secured and registered in this corner, because this is where we're going to set X and Y 0, this corner of the new fixture plate I will register exactly with the fixture plate that's beneath it. Once that's in place, I'm going to drill and ream a row of holes through both plates, and these holes will be sized exactly for dowel pins. Each of the holes is exactly 1 inch from the next one. So what this would allow me to do is, when the plate is in place, if I put several dowels in here, it's registered. And then later, when I have to move it to the left, I can unscrew it, lift it up, move it 3 inches over to the left, and then using these dowel pins, just re-register it. That should re-register it exactly, except that it is now 3 inches to the left. I'm also going to drill a hole here and here for dowel pins, so that the frame itself is registered to the fixture plate. Then I can come in, and the first step would be to use a large end mill and clear out this hole, and then use a smaller end mill and run a finishing pass around it. Next, I can take a nice end mill and run it around and cut out this part. Once that's done, now I take these screws out, which are holding this fixture plate to the one beneath it. I move it 3 inches to the left, just counting dowel pins, and re-register it by placing the dowel pins back in, but now it's over farther. So this part here is hanging 3 inches over to the left of the underlying fixture plate. After I move the fixture plate 3 inches to the left, the machine controller still thinks that XY0 is here, which would be wrong because the part is now over here. But that's very easy to fix. I can just tell it that X is now at 3. So now from the machine's perspective, 3 is here, X3 is here, which is true because we've shifted the part over 3 inches. Well, obviously, if 3 is here, then 0 is 3 inches to the left of that. So as far as the machine is concerned, nothing has changed. It doesn't know what we've done here, but it doesn't care. 0 is still here because this is 3. And when we begin machining the other part here, everything will be fine. So when we machine this part, again, everything is always relative to XY0. So we've shifted everything over to the left, but we've also tricked the machine, or not tricked it, we've informed it that we are now 3 inches further in. Once this is done, we're going to flip the part over. And because we have these dowel pins here, we can relocate it exactly where it needs to be back on our new fixture. And then we can come along and run this same toolpath and cut this part out. Well, that's enough theory. Let's go make some chips. First, we want to find X0, and then we want to find Y0. The first step after the fixture is mounted is to drill some mounting holes that we're going to use to hold down the plate that we're going to cut the frame from. These need to be tapped, and my mill doesn't do tapping, but what I do is I use the mill to guide the tap into the hole. That keeps it nice and straight. Once that's done, we screw down the piece of brass that we're going to cut from. Make sure everything is very tight. We don't want this piece moving. The first step uses a 3/8 inch end mill to clear out the large hole in the top of the frame. The frame is 3/16 of an inch thick, and I'm only going to 1/3 of that depth on each pass. So it'll take 3 passes to get to full depth. I've now sped up the video, and when I do, in this video, it's going to be 8 times normal speed. Which, of course, is the rate I would like my machine to be able to run. At this point, we're down to full depth. You can see the aluminum fixture beneath as we cut through the piece of brass. Now I've switched to a 1/8 inch end mill, which I'll use for the rest of the job. Right now I'm running a finishing pass, removing the last 15 thousandths around that hole that we just cut. And now we begin cutting the profile of the frame. Once again, I'm only going to 1/3 of the depth of the brass. My mill just can't handle a deeper cut than that. Now I begin the second pass. So we're now 2/3 of the depth. And this is the final pass. We're getting down to the bottom here. Keep in mind I'm leaving around 15 thousandths around the perimeter, and we're going to go back in a moment and clean that up. Here we go. When we clean it up, I reverse the direction, which is called climb milling. And it gives you a cleaner cut when you're removing a little bit of material. Now the left half of the frame is complete, and it's time to shift everything over 3 inches. So I remove the stock. And now I remove the fixture plate. And we're going to go 1, 2, 3 inches over to the left. I reset this dowel pin. And re-register it on the 4th pin in, which is 3 inches to the left. Now I screw the fixture back down, nice and tight. Put the dowel pins back for locating the stock. And place the stock back in position, which should register it exactly where it was before. Screw it back down. And now I've jogged the machine to XY0, and as you can see, it's measuring 3 inches in X. So now I go to the machine controller, and I tell it X is now at 3. Now it's time to machine the top half of the right side of the frame. Here's a closer look. And this is the finishing pass. You can see the cleanup happening right now. This leaves us with one more operation to do. Which is to flip the stock over, re-register it on the dowel pins, and begin the final pass of the cut. Now at this point I'm using the exact same toolpath I used before the flip. I'm just running that section of code a second time. And now the part's complete. This is the moment of truth where we see how well a fixturing worked. And as you can see, there's a very, very slight indentation where the 2 toolpaths met. I can barely feel it. That indentation is probably less than 1/1000th of an inch deep, which means it'll be very easy to sand that out. So the technique worked. Later in this series, I'm going to do an entire video on sanding and polishing, but I just wanted to show you on this scrap piece from the frame that with a few minutes of sanding, I can bring it to a beautiful mirror finish. These little scratches that you see here are only visible because we're looking at this under magnification from the video camera. In real life, you can't see those at all. But again, I just did this very quickly. When I do the real frame, I'll make sure that there are no scratches visible. I went off and made the second frame, which is the back of the clock, so this part of the operation is now complete. I'm not sure whether we answered the question of whether CNC is easier than working by hand, but we've certainly shown that CNC isn't easy. If you like this video, please let me know by hitting the like button. I also enjoy reading your comments, and I'll respond to as many of them as I can. If you'd like to be notified when I post additional videos on the build of this clock and other projects, please click the subscribe. If you're interested in my other work, you can find it at my website, which is www.zeman.com. I will see you all soon.